A real number that is not rational. Irrational numbers. In context, key figure Hippasus, 5th century BC. Field, number systems. Before, 19th century BCE, cuneiform inscriptions shown that the Babylonians constructed right-angle triangles and understood their properties. 6th century BC, in Greece, the relationship between the side lengths of a right-angle triangle is discovered and was later attributed to Pythagoras. After 400 BC, Theodorus of Cyrene proves the irrationality of the square roots of the non-square numbers between 3 and 17. 4th century BCE, the Greek mathematician Eudoxus of Cnidus establishes a strong mathematical foundation for irrational numbers. Any number that can be expressed as a ratio of two integers, a fraction, a decimal that either ends or repeats in a recurring pattern, or a percentage is said to be an irrational number. All whole numbers are irrational as they can be shown as fractions divided by 1. Irrational numbers, however, cannot be expressed as a ratio of two numbers. Hippasus, a Greek scholar, is believed to have first identified irrational numbers in the 5th century BC as he worked on geometrical problems. He was familiar with the Pythagorean theorem, which states that the square of the hypotenuse in a right-angle triangle is equal to the sum of the squares of the other two sides. He applied the theorem to a right-angle triangle that has both shorter sides to 1. As 1 squared plus 1 squared equals 2, the length of the hypotenuse is the square root of 2. Hippasus realized, however, that the square root of 2 could not be expressed as the ratio of two whole numbers. That is, it could not be written as a fraction, as there is no rational number that can be multiplied by itself to produce precisely 2. This makes the square root of 2 an irrational number, and 2 itself is termed non-square or square-free. The numbers 3, 5, 7, and many others are similarly non-square, and in each case, their square root is irrational. By contrast, numbers such as 4, 2 squared, 9, 3 squared, and 16, 4 squared, are square numbers with square roots that are also whole numbers and therefore rational. The concept of irrational numbers was not readily accepted, although later Greek and Indian mathematicians explored their properties. In the 9th century, Arab scholars used them in algebra. Pictured here, Hippasus may have encountered irrational numbers while exploring the relationship between the length and side of a pentagon and one side of the pentagram formed inside it. He found that it was impossible to express it as a ratio between two whole numbers, in decimal terms. The positional decimal system of Hindu-Arabic numeration allowed further study of irrational numbers, which can be shown as an infinite series of digits after the decimal point with no recurring pattern. For example, 1.010010001 with an extra zero between each successive pair of ones, continuing indefinitely, is an irrational number. Pi, which is the ratio of the circumference of a circle to its diameter, is irrational. This was proved in 1761 by Johann Heinrich Lambert. Earlier estimations of pi had been 3 or 22/7. Between any two rational numbers, another rational number can always be found. The average of the two numbers will also be rational, as will the average of that number and either of the original numbers. Irrational numbers can also be found between any two rational numbers. One method is to change a digit in the recurring sequence. For example, an irrational number can be found between the recurring numbers 0.124124 and 0.125125 by changing 3 in the second cycle of 124, and to give 0.124324, and doing so again at the 5th, 9th, increasing the gap between the replacement 3s by 1 cycle each time. One of the great challenges in modern number theory has been establishing whether there are more rational or irrational numbers. Set theory strongly indicates that there are many more irrational numbers than rational, even though there are infinite numbers of each. Hippasus. Details of Hippasus' early life are sketchy, but it is thought he was born in Metapontum in Magna Graecia, now southern Italy, around 500 BC. According to the philosopher Iamblichus, who wrote a biography of Pythagoras. Hippasus was the founder of a Pythagorean sect called the Mathematici, which fervently believed that all numbers were rational. Hippasus is usually credited with discovering irrational numbers, an idea that would have been considered heresy by the sect. According to one story, Hippasus drowned his fellow Pythagoreans, threw him over the side of a boat in disgust. Another story suggests that a fellow Pythagorean discovered irrational numbers, but Hippasus was punished for telling the outside world about them. The year of Hippasus' death is not known, but is likely to have been in the 5th century BC.